So far, these systems of equations that we've worked with have only had two variables, usually an x and a y, and two equations. Today we're going to look at it with three variables, an x, y, and z, and three equations. So it will look something like this right here. Now, we have three equations in this case, and z, the third equation, is already given to us as equal to 2. And so this makes it a pretty fast solve. They do get more complicated as we go along, but since z is already solved for, we can substitute it into one of the equations. Now, as I go through these, I'm going to start numbering these equations as equation 1, 2, and 3. Sometimes we will come up with an equation 4 and 5, but I think it's easier for us to talk about if we number the equations as we go. So equation 3 gives us z equals 2. I'm going to put that into equation 2 and solve for y. So I get y is equal to, actually before we do equals, let's say y plus 3 times 2 equals 5. We don't do it all in one step. 3 times 2 is 6, so y plus 6 is equal to 5. And then subtracting 6 from both sides, I get y equals negative 1. So I got z equals 2, y equals negative 1. I'm going to go up to equation 1 now and put those variables in and solve for x. So x minus 2 times negative 1 plus 3 times 2 equals 9. 3 times 2 is 6. Negative 2 times negative 1 is positive 2. 2 plus 6 is 8. And x is equal to 1. So I got x equals 1, y equals negative 1, and z is equal to 2. We're going to do this just like we did when we solved for two variables, and we put it in an ordered pair. This is going to be an ordered triplet, and we put this ordered triplet in as x, comma, y, comma, z. So x is 1, y is negative 1, and z equals 2. So that's our first one. Not too bad, and like most math introductions, they start you off with an easy one where you already know what z is. But it's not always quite like that. Let's look at our second example here and see what we get. So our second example has, once again, three equations to it, and I've kind of left a space there right here because there is no z there. You can add it as 0z if you want to, but just to kind of let you know, we won't always do that, but on these examples today, I kind of leave a space or kind of like a placeholder there for it to let you realize, like, hey, we have 0 z's in that equation. So once again, we're going to label these equations equation 1, 2, and 3. And what I like to do is pick two equations and eliminate one of the variables. So I'm going to use equation 1 and 3 here, and I'm going to pick a variable to eliminate. I'm going to eliminate z in those equations. So to get the z's to be eliminated, I'm going to need that same coefficient in front of the z, and one to be positive and one to be negative. So if I multiply equation 1 times 5, so I'm going to multiply this whole equation right here times 5, and multiply this one by negative 3, I'm going to obtain negative 15z here and positive 15z there, and they'll add up and cancel out. So that's just what I'm going to do. So this is going to be equation 1 times 5, and that's going to equal, let's see, multiply each term by 5. You get 5x minus 10y plus 15z is equal to 45. And then I'm going to do equation 3 times a negative 3, and this gives me negative 6x plus 15y minus 15z, and then what is this, 51, minus 51. And now I can add these equations, and I'm eliminating the z here. So adding these equations, I get negative x plus 5y. These z's cancel out, and then this is going to give me equal to negative 6 when I say 45 plus negative 51. So this gives me a whole new equation. Notice it's still in two variables, and I'm going to call this equation 4. And sometimes we will come up with another one, and we'll see that in a moment where we come up with equation 5. But here's the key thing. Let me zoom out so you can see a better picture of what's going on. The second equation did not have a z in it. So I chose to take equation 1 and equation 3 and put those together and eliminate z. This gives me equation 2 and equation 4 without a z in it. And I can use those two equations together to figure out x or y, whichever I choose. So I'm going to write equation 2 right here next to equation 4. So equation 2 is negative x plus 3y equals negative 4. Notice this is just like what we had when we had systems of equations in two variables. So I'm going to pick one and eliminate. I'm going to use elimination here to solve for y. So I'm going to eliminate the x by multiplying this equation right here, equation 2, by negative 1. So when I multiply by negative 1, this becomes positive, this becomes negative, and that becomes positive. So when I add these, the x's cancel out, and I get 5 minus 3, which is 2, and negative 6 plus 4, which is negative 2. And solving for y, I get negative 1. So y equals negative 1. That's the first variable I've been able to solve for out of all three of these variables. Now, if I go back and look at equation 2, I should be able to solve for x here. So putting negative 1 into the equation, I get, this is equation 2, negative x plus 3 times negative 1 equals negative 4. And so I get negative 3, negative x minus 3 equals negative 4. Add 3 to both sides, and I'm going to get negative x equals negative 1, or x equals 1. So I got a value for x, I've got a value for y. Now I need to figure out what my z value is. So earlier we eliminated z, we want to go back and figure out what it is now. You can pick equation 1 or equation 3, it doesn't matter, and substitute your x and your y values in for that. I'm going to pick equation 1. So with equation 1, we have x minus 2y plus 3z. And this equals 9. So putting in x equals 1 and y equals negative 1 gives me 1 minus 2 times negative 1 plus 3z equals 9. Negative 2 times negative 1 is positive 2, so 1 plus 2 plus 3z equals 9. Subtracting 3 from both sides gives me 3z equals 3. Not 3, 6, because I'm subtracting, right? Not dividing. 3z equals 6, and then dividing by 3 gives me z is equal to 2. So with z equaling 2, remember we're going to put this in order of x, y, z. So it's going to look like this, x, comma, y, comma, z. X is 1, y is negative 1, and z is equal to 2. All right, let's try out another one here. So pause the video and give this one a try. All right, I trust that you've given it your honest attempt. Let's take a look and see if you got it right. So once again, I'm going to go through and I'm going to label this 1, 2, and 3 again. That way we can talk about it easily, whether it be in my class or whether you're listening at home on the video, you know which equation I'm talking about. And I'm just going to pick a variable to eliminate. So I need to take two of these equations and eliminate one of the variables. So looking at this, now keep in mind, you may have done yours differently. It's okay, just so long as your answer comes out to be the same. But looking at it, I've already got an x with a coefficient of 1 and an x with a coefficient of 1. That's going to make life the easiest for me if I take equations 1 and 3 and eliminate the x's. So to do that, I'm going to say, all right, I've got equation 1 and equation 3 I'm going to pair together. I'm going to multiply equation 1 by negative 1. Once again, you could have done this differently. This is just the route I'm choosing to take. So when I do that, all these signs flip in here. So this gives me negative x plus 3y minus z equals a negative 1. Remember, each term must be multiplied by whatever number you're talking about. In this case, since it's negative 1, it's just flipping those signs. Now, I'm going to pair with that equation 3, and I'm just going to write it down like it is, x plus 2y minus 3z equals negative 1. And because negative x and positive x are opposites, when I add them, I get 0 x's, or another way we like to say it is they cancel out. 3 plus 2 is 5, so I get 5y. And negative z minus 3z gives me negative 4z. And negative 1 plus negative 1 is negative 2. Now, that eliminated the x. And I'm going to call this equation 4. Now, the only thing about this is, unlike the last one, let's look at the last one that we just did. When we eliminated, what did we eliminate? The z, equation 2 didn't have a z in it. So I could just combine equation 2 and equation 4 and move on from there. Here, when we look at equation 2, it does have an x in it. So it hasn't been eliminated. And so what I need to do is take equation 2 with either 1 or 3, I get to choose, and eliminate x out of it. So let's do that. I'm going to take equation 1 again, and I'm going to take equation 2 this time. So equation 1 and 2, and I want to eliminate the x again. It has to be that same variable I chose for the first set. And so to eliminate 2x, I need to make this look like negative 2x. So I'm going to multiply everything in equation 1 by negative 2. So doing that gives me negative 2x plus 6y minus 2z equals negative 2. So I've taken each one of these terms and multiplied it by negative 2. Then I'm going to write equation 2 underneath it. 2x minus y minus 2z equals 2. And I'm going to add these. Negative 2x plus 2x, they cancel out. 6 minus y is 5y. Negative 2z and negative 2z gives me negative 4z. And negative 2 plus 2 gives me 0. I'm going to call this equation 5. Now looking at this, both equation 4 and equation 5, they don't have an x in it. So I'm going to pair up equation 4 with equation 5 and eliminate one of the other variables there. So let's see. I'm going to choose to eliminate the y, which means, notice they have the same coefficient, 5y and 5y. So I'm just going to write down equation 4 below. But when I do that, I'm going to multiply equation 4 by a negative 1. I'm just writing this right here to remind me what I'm doing, and also so you can see in my notes what's going on. Negative 1 times equation 4 is what I'm doing. So equation 4 times negative 1 gives me negative 5y plus 4z equals positive 2. And here when I add these up, 5 minus 5 gives me 0. So I end up with 0y, or just 0. You don't have to write anything down there. Negative 4z plus 4z just so happens to also cancel out the z. Doesn't always happen, but in this case it canceled out both variables. So I get just 0 on the left side, and 0 plus 2 equals 2. Now, 0 does not equal 2. That is not a true statement. So just like when we did two systems of two variables, because I get a non-true statement here, that means that there is no solution. Now, sometimes that throws students off when they do all this work and they get no solution, and it's okay to go back and check your work. All right, so go back and check it if you don't believe me, or if you're doing your own homework, test, or quiz and you get a little suspicious, go back and check it. Start it over, or maybe choose a different variable to eliminate in the beginning and see if for some reason you made just a simple mistake in there. But in this case, it's no solution. Now, had it been something like, had this been like a 5z here and we add them, got z equals 2, then we're going to say, okay, we figured out what z is, go back and figure out y, and then go back and figure out x, just like we did on the last problem. So you can continue on there when you need to. All right, let's look at another one. Pause the video and give this one here a try. All right, I've taken that you've given it your best attempt. Let's go ahead and label our equations. This can be equation 1, equation 2, and equation 3. And so I'm going to choose a variable and eliminate it right off the bat. Well, looking at this one, I don't have an x value on equation 2. And looking at equations 1 and 3, there's not a whole lot of work that I have to do to eliminate x if I were to add those two up. So that's what I'm going to do. I'm just going to add equation 1 and 3 together. Let me write down equation 1 right below equation 3 here. And I'm just copying it down so I can add them easier. So x plus y minus 3z is equal to negative 1. And adding these, I get negative x plus x gives me 0. 2y plus y is 3y. And 0z minus 3z is just minus 3z. And that equals negative 1. No, not negative 1. I got to add those two, don't I? That equals 0. So this is what I call equation 4, when I combine equation 3 and 1. Now I have equation 2 here with the x already eliminated, so I'm going to pair up equation 4 and equation 2 and see what I can figure out about either z or y. So y minus z equals 0. And so I got to pick one of these and eliminate it. So I'm going to take and eliminate the y's. So if I multiply equation 2 by negative 3, what I get is negative 3y, and negative 3 times negative 1 is positive 3z, and then just 0 right there. And now I'm ready to add to eliminate those y's. So 3y minus 3y is 0, and negative 3z plus 3z is also 0. Here's another case where both variables just so happen to get eliminated. And then 0 plus 0 is 0. So I end up with 0 equals 0. Now this is a true statement. 0 does equal 0. So just like when we had systems with two variables, when you get a true statement, all the variables get eliminated and you get a true statement, that means that there are infinitely many solutions. All right? So this is infinitely, you don't even have to write the word infinitely many solutions. Well, yeah, go ahead and write that. Infinitely many solutions. It's a whole bunch of solutions. More than you can count, right? All right. So had you gotten it down to a z or y equal to a number, you could go back in and back substitute it in and figure out the other three variables. What I recommend you do is take notes as you do these videos and then try extra problems. So what I'm going to do is come up with another video that's just got a ton of these examples in there and we can work through them together. So be sure to watch that video as well. But this was just an introduction so you could see how we could get three variables, pair them down to two variables, and then solve for that single one, back substitute it in, and figure out x, y, and z. We also saw how we can get infinitely many solutions or no solutions at all. So watch that next video, get your practice in, and let me know if you have any questions. Thanks for watching.